All right, folks. So we are going to go through some practice problems real quick here, just so you guys are aware. These practice problems are from the end of the section on two variable data analysis. If you're reading this book, and I really suggest that you do because it's not very big, right? A big chunk of the book is strategies in the beginning. They're kind of talking you through the AP test and giving you strategies. There's diagnostic tests in here. So a pretty small chunk of this book is actually teaching you content, and it's in plain language, and it's a pretty quick read. And then at the end of every section there are practice problems, and if you go to the end of the practice problems, they'll give you the solutions all explained out, to the multiple choice, to the free response. So this really is like a gold mine in terms of studying. So if you want to follow along in your book, you can see the question numbers in here, and you can always look up the solutions to these problems after. And I really do suggest that you guys try a bunch of these practice problems on your own because it's going to help. Okay, but let's go through some of these quick here on the next 5 slides. So this one says the regression line for the two variable data set given above is y hat equals 2.35 plus 0.86x. What is the value of the residual for the point whose x value is 29? So remember, a residual is equal to some actual y value minus the y value that my regression line predicted. Okay? If my data point falls above the line, that means y is going to be bigger than the prediction, and I'll have a positive residual. If my dot falls below the line, that means my actual y value is less than what the line predicted, and I'm going to have a negative residual. Okay, so the first thing I need to look at is I need to look at my chart, and I need to say, all right, when x is 29, the predicted y value is 25. So there we go. 25 minus, now I need to figure out, well, what does the regression line predict the y value is going to be when the x value is 29? And I can get that just by substituting this into my calculator. 2.35 plus 0.86 times an x value of 29. So I'll do that, right? What do we got here? 2.35 plus 0.86, and the x value they want us to predict on is 29. So if you look here, I get 27.29. So my regression equation predicted that somebody with an x value of 29 would have a y value of 27.29. Okay, so what's the residual going to be? It's going to be 25 minus 27.29. That looks like a residual of negative 2.29. Okay, so that one's not so bad. And if you want to just kind of imagine here for a second what that's going to look like. All right, here's my regression equation, right? And here is maybe the x value 29, right? And the actual data point when x was 29 was 25, right? So if I draw a dashed line across here, right, the actual y value is 29, but this has a negative residual of negative 2.29. It fell below the line. The line predicted that I would have a y value of 27.29, like I said before, right? So the actual data point came up short of the regression line and left us with this negative residual of negative 2.29. All right, so that's one. Now, for this one, it says an experiment is conducted on the effects of having convicted criminals provide restitution to their victims rather than serving time. The following table gives the data for 10 criminals. The monthly salaries X and monthly restitution payments Y were as follows. So basically they're saying if somebody does something bad to you, instead of sending them to jail, there is some sort of experiment going on where instead of sending the person to jail, we make them pay their victim a restitution payment, and that restitution payment is based on their monthly salary. Okay? Part A says, find the correlation between X and Y and find the regression equation that can be used to predict the monthly restitution payments from the monthly salaries. So they want us to run a regression equation here. So in order to do that, let's see if I can't put this here and put my calculator over here. Beautiful. And what I want to do is if I want to run a regression equation and calculate correlation, the first thing you got to do is you got to make sure your stat diagnostics are on. I'm going to try and make sure I turn all those on for you guys the day of the test. When I bring the calculators over, I'll make sure that these are all turned on. So you really don't actually have to worry about that. What you do have to worry about first is entering the data into your lists. So you have to hit stat and then you have to hit edit. Okay, and I went ahead beforehand and I plugged the data in as to not waste video time plugging the numbers into the list. So just the one thing you have to make sure is you got to make sure that each X is matched up with the appropriate Y. So you can see in list 1, I put 300, which was the first X value. In list 2, I put 200, which was the first Y value. And I put all the X values in, then I put all the Y values in, and then I just did a quick double check to make sure they were paired up appropriately. Okay? Once your data is in the lists, you're going to hit stat, calc, and don't get confused here, right? When we were dealing with one variable data, we did one variable stats, but we're not going to use two variable stats, okay? That's not the linear regression button that we want. The linear regression button that we want is either function 4, linreg ax plus b, or function 8, linreg a plus bx. The only difference is the format that the calculator is using for the equation of the regression line. So during the year, I taught you guys to use 4, linreg ax plus b, because this is the equation for a line you guys are used to. If I ask pretty much any of my classes, what's the equation for a line? They just spit out mx plus b. Sometimes I don't even think they know what they're saying, but this is all burned into your head, right? I'm going to use function 8 here, though, just because the formulas on the sheet, if I go back, the formulas on the AP exam sheet, if I go way back here they are, and try and clean some of this out, they give it to you. They give you the linear regression formula is y hat, or the predicted y value, is equal to a plus bx. So they're using a as the y-intercept and b as the slope. So in my calculator, I'm going to match that. Okay, I'm going to do the same thing that they did. I'm going to pick function 8. It doesn't matter. You can pick function 4. Just realize if you pick function 4, that a is actually the slope. So when you're looking at the formula sheet, right, this is slope. They're telling you this is the formula for the slope of the regression line, because in their eyes, they're using b to represent the slope. All right, so I'll use function 8. All right, I got function 8 here. And I'm going to make sure I put all my x's in L1 and my y's in L2. So it should say that by default, but if for some reason it doesn't, you could always change it by hitting second list. And you can choose any of the other lists where you put your numbers. All right, but I don't want to do that now. So stat, calc, I want to do linreg function 8. Oh, no. What's going on here? Come on. Let's try again. Stat, calc. Only want function 8. Please don't go down forever. Function 8. There we go. Got it. Okay. Got my X list and my Y list right. You hit calculate, and boom, it's going to give you the regression equation. So I can write that up here now, right? My Y hat, my predicted Y value, Y hat, is going to be equal to negative 56.22, negative 56.22 plus, what did they give me for the slope? The slope is 0.4649, 0.4649 times, whoops, let's try that again, times x, okay? And there's your regression equation, right? And they also ask us, right? They ask us for correlation too. So I can pull that up on my calculator. The correlation R is 0.972, right? So very close to +1. That indicates a very strong positive linear relationship in this data. In other words, as the X's are increasing, the Y's also tend to increase. And for the most part, you can see that's true, right? As I move from left to right, these X's are in order. You can see it's not a perfect relationship, right? We're generally increasing though. You can see here we didn't increase. Here we didn't increase, but for the most part, the Y values are going up, right? That's not why we didn't get a perfect one, but we got pretty darn close. Okay. Draw the scatter plot of the data and put the least squares regression line on the graph. I'm not going to do this. All right. Here's why. If you guys are asked to make a scatter plot on the exam, that's a home run because all you're doing is plotting XY pairs. And you guys should know how to do this all the way from Algebra 1, right? If they give you a graph, you guys need to know how to scale your axis, label your axes, and plot these points on a coordinate plane. I have full faith that everybody can do that, right? And then if they want you to graph the least squares regression line too, that's fine. You have the equation. Plug it into y equals on your calculator, and then check your table and plot your points for the regression line. Okay, so if you're asked to make a scatter plot on the exam, I think we can all do that. All right, so let's skip to part C. Interpret the slope of the regression line in the context of the problem. So the slope of the regression line is 0.4649, and within the context of the problem, right, the x variable represents the criminal's monthly salary, and y hat represents the value of their restitution payment. So basically, for every dollar that I increase x, right, what is the slope telling me? For every dollar increase in monthly salary, my restitution payment is going to increase by 0.4649. All right. In other words, in every dollar increase in monthly salary, I am going to owe an additional 46.49 cents in restitution payments. Okay, so that's not so bad. That's just interpreting the slope. And then D, how much would a criminal earning $1,400 per month be expected to pay in restitution? I just got to plug 1,400 in here in my calculator, and it'll tell me about how much they should pay in restitution. So negative 56.22, right? Let me get out of here. Negative 56.22 plus 0.4649 times 1,400. And my predicted restitution payment would be $494 and 64 cents. Okay, so that's just creating a regression line, interpreting the slope. If they ask you to interpret the y-intercept, right, this actually doesn't make sense in the context of the problem, and that's okay. That happens with regression lines. If somebody made $0 a month, they would be expected to pay negative $56.22 in restitution, right? Obviously, within the context of the problem, the model only makes sense if you're making some amount of dollars per month, right? It doesn't really make sense if you're not making any money, you wouldn't have any money to pay in restitution, right? But we built the regression line, we identified the correlation, and we even made a prediction about a y variable based on an x. So we got 1, 2, 3 questions left. There's nothing on the last slide. Not bad. All right, so here we go. This one says, suppose the least squares regression line for predicting weight in pounds from height in inches is given by weight. Notice there's a hat on the weight because it's a prediction, is equal to negative 115 plus 3.6 times the height. Which of the following statements is correct? So 1 says A person who is 61 inches tall will weigh 104.6 pounds. This is not true, right? If you plug in 104 pounds into the regression equation, or I'm sorry, if you plug 61 inches into the regression equation for height, you are going to get 104.6 pounds, right? Watch. Negative 115 plus 3.6 times, we said 61 inches, right? And it is going to give me 104.6. And this is a trap answer, okay? Because of the word will. Remember, regression equations are predictions. They do not represent reality. So a person who is 61 inches doesn't have to be 104.6 pounds. It's what my model predicts somebody who's 61 inches tall is going to weigh. So answer choice 1 uses language that's too strong. If it said a person who is 61 inches tall is predicted to have a weight of 104.6 pounds, then this answer would be correct. But because it's saying that a person who is 61 inches tall will definitely weigh 104.6 pounds, this answer no longer makes sense. All right, so 1 is out. 2 says for each additional inch of height, weight will increase on average by 3.6 pounds. And the key word here is on average, right? It's not saying, right? We're not saying that every time we add an inch of height, somebody's weight is definitely going to go up by 3.6 pounds. It's saying that for the average person, the taller you get, the heavier you're going to be. And every time we add an inch to somebody's height, on average, they're going to increase weight by 3.6 pounds. It doesn't say that it's definitely going to occur, all right, because it says on average. So answer choice 2 looks good to me. And then answer choice 3 says there is a strong positive linear relationship between height and weight. Here's the thing. They don't give us the correlation coefficient. Okay, they don't give us the scatter plot. They don't give us a residual plot. So we can't make that determination. Okay, all they give us is the regression equation, right? So we can assume that there's probably a strong relationship between weight and height, but we do not know if it's linear because we don't have the data. We don't see the scatter plot. Okay, and if we did see the scatter plot, all right, they might even want to give us the residual plot so that we could determine if a linear model is appropriate. None of that's happening here. So this answer choice 3 is a giant assumption. Okay, so it's got to be B, right? This is the only thing that's definitely true. 3 could be true because they are giving us a least squares regression model, right? But we don't have the visual. We don't have the scatter plot to back that point up. All right. What do we got left here? We got 2 left. Okay, this one's pretty tricky, but I'm going to do it with you guys, right? So it says the correlation between 2 variables, x and y, is negative 0.26. A new set of scores, x star and y star, is constructed by letting x equal negative x and y star equal y plus 12. What is the correlation between x star and y star? So here's what we got. I'm going to draw you guys a coordinate plane, and I'm going to try and make sense of this question here. All right, I can do better than this. Let's do that and that. All right. So the first thing I'm going to do is I'm going to try and draw a correlation of negative 0.26. So that is going to be a loosely downward sloping line. All right. And maybe I'll do like 5-ish data points to make this as simple as possible. All right. So here is our data points. Okay, this kind of looks like a negative 0.26 correlation, very loose downward sloping pattern, right? I'll try and draw in a least squared regression line here, right? It's probably a downward sloping pattern, but it's very loose. So what are they asking us, right? they're saying, all right, let the x coordinate, this new coordinate, x star, is now going to equal negative x. So think about it. These are all positive x values right now, right? But they want us to flip this over the y-axis, okay? So these data points are going to be flipped, and also their y values are going to be shifted up 12. Now, the shifting up of 12 is not going to change a thing, right? Just to forget about the flipping on the x for a second. Imagine taking all these data points and shifting them up 12 units. If the entire pattern is shifted up 12 units, the correlation is not going to change one bit, right? It's going to be the exact same pattern. It's just going to be higher up on the y-axis. So let's not even worry about shifting the dots up 12 units, right? Because that's not going to change a thing. What is going to change a thing is going to be this x star equals negative x. They want us to take all these data points and flip them over the y-axis. So I can reflect over the y-axis, right? So this is the same exact data point. I'm not going to shift it up 12 because, like I said, that's not going to make a difference. But if I flip this over the x-axis and then I flip this one over, I'm sorry, I'm saying the x-axis, I mean the y-axis. We're flipping the x variable over the y-axis, okay, right? X equals negative x. This is where all your positive x values are. This is where all your negative x values are. So if they're telling you we're going to transform this thing by letting x equal negative x, we're flipping all these points over the y-axis, right? So this one has to get flipped over the y-axis. And I'm just doing like a rough flip here, right? So I kind of tried to make mirror images here. 1, 2, 3, 4, 5. They're, roughly equivalent. And again, you can imagine that these data points are also shifted up 12 units. Okay. But what do we notice about the pattern now? The pattern is different than it was before. It's the same strength, right? The dots are still loosely packed. So this 0.26 is going to be the same. But the problem is if I let x star equal negative x, meaning I reflected this whole pattern over the y-axis, the dots are going up now, not down. So it's got to be B. Okay? The correlation strength itself didn't change, but the direction did because I flipped this thing over the y-axis, right? So this dot right here, right, if you just think about it intuitively, this dot right here was pretty close to the y-axis, and it was high up. When I flipped it over the y-axis, it needed to stay close. This one was further away from the y-axis over here, so when I flipped it, I needed to make it further away, right? This dot probably should have been moved over like here a little bit if I was doing a really good job reflecting, all right, so that they look like mirror images. But the point is, the pattern is now upward sloping, all right? And one more practice question. It says a study done on the relationship between high school grade point average and scores on the SAT, or a study was done on the relationship between high school grade point average and GPA and scores on the SAT. The following 8 scores were from a random sample taking the exam. What percentage of variation in SAT scores can be explained by the regression of SAT score on GPA? So basically, they're asking us, whenever you see what percentage of variation in the y variable can be explained by the x variable, right? What percentage in variation in SAT scores can be explained by my GPA? They're asking me for R squared. Okay, so you guys can bear with me here. I'm going to plug these numbers in live. All right, and we're going to calculate R squared together, right? As long as our stat diagnostics are on, we can go to stat, edit, and we can clear these lists out, right? Don't delete them. If you delete the column heading, the list will disappear, and I will not be able to get it back for you on the day of the AP exam. All right, so I'm going to take this first row. I'm going to put it in L1, so that's 3.2, 3.8, 3.9. These are all GPAs. 3.3, 3.6, 2.8, 2.9, and 3.5. And then my L2s, I have 725, 752, 745, 680, 700, 562, 595, and 730. Okay. And I'm just going to hit, right, stat, calc. I'm going to go to linreg. This time it definitely doesn't matter whether you pick function 4 or function 8 because I don't care about the regression line here. I just care about r squared. Okay, so I'm going to come down here and I'm going to hit r squared or calculate. And I'm going to see r squared comes out to 0.788. And here we go, 78.8, right? R squared, when you're working with r squared, it's always a decimal. All right, when you're interpreting it, you can convert it into a percentage, which is what they did in the answer choice here, because that's what the question asked. But if you needed to calculate r or r squared, you always have to work with them as decimals, right? If I didn't have r and they said r squared is 0.788, right? Or if they said r squared was 78.8 and they asked you to find r and you needed to take the square root, you can't just take the square root of 78.8. You got to turn it into a decimal first. So if they gave you r squared of 78.8%, you can convert it to a decimal and take the square root, and then you would have r. And likewise, if you have r and you square it, obviously you're going to have your r squared. Okay? So that was it. For this one, was pretty easy. You just plug the numbers into the lists, you run the regression, and you pull r squared right off your calculator. All right? And I think that's all I have. Okay, so there we go. Our shortest video yet. I'm going to stop this one here. Happy studying, ladies and gentlemen.